Greetings and welcome, friends. Mr. Waddy and his Algebra Buddies here. We've been talking about exponential equations and exponential growth and decay. Exponential equations are of the form y equals a times b to the x. Sometimes we have like a minus h and a plus k thrown on that if we translated the graph. And yesterday we had this equation, y equals a times 1 plus r to the t. Okay, so this is exponential growth, and if it's a minus r, then it was decay. All right, so it says identify the initial amount, a, and the rate of growth, r, as a percent of the exponential function, then evaluate when t equals 5. So in this problem, a is equal to the 1500, okay? And to find r, I'm going to have to do a little bit of work. This value here is the equivalent of b, and I want to point out that b is equal to either 1 plus r or 1 minus r. Question, comment, yes. Both of these are on the test, yeah. So, if b is equal to 1.074, and I want to find r, I can actually plug that in over here and then find r accordingly. So, if I want to find r, I know that in this case, actually, do you guys suspect this is growth or decay? Growth, because this number is bigger than 1. Okay, so it is growth, so I'm going to use the plus version of this formula. So I'm going to have 1.074 is equal to 1 plus r. And if I want to solve for r, question, comment? This is exponential growth or decay. Kind of. To solve for r, I'd subtract 1 from both sides, and I end up getting r equals 0.074. They asked for it as a percent, so that means r is equal to 7.4%. That means for this model, this situation, the values are growing by 7.4% each time period. Could be years, could be days, eons. Depends. Like, I mean, if that's an interest rate that a bank is giving you, pretty good. Yeah, it all depends on what it represents. Then they told us that t was equal to 5. They wanted us to evaluate. So let's plug that in like so. So f of 5 now would equal 1500 times 1.074 to the 5th, right? So if I plug in 5 for t, 1.074 raised to the 5th, I get 1500 times 1.43, we'll call it. I guess we'll round to 2 decimal places. And f of 5, right? Jake, you with us? You're not just playing games on your Chromebook there? You actually don't even need your Chromebook to write this down. So I get 2143.45. That means 5 time periods from now or whatever. Actually, oh, they said to round to the nearest tenth, so 0.5. So in 5 time periods, it went from 1500 to 2143.5. Yeah? All right, I'll hold for a moment. Yeah, question. Okay. So the r is representing the percent that it's growing each time period. Usually we've been working with t is equal. So it's growing by 7.4%, which means that the b value was like 107.4%. So like to grow by 7.4%, the number has to be 107.4% its previous value. I use plus when it was bigger than 1, and I would use minus, the minus r less than 1. This is a model for when I've got kind of more of these word problem situations, and they both are technically exactly the same thing, This was used kind of more for just like graphing exponentials, arbitrary situations that aren't necessarily related. Question. I was using this equation. I'll do some more. Let me cruise through a bunch of these and we'll get used to it. Yep, is a formula that you could use to calculate it. Yep, b equals 1 plus r, or b is equal to 1 minus r when it's exponential decay. So let's see. Well, let's just cruise through some. I'll answer. You'll see some themes as I go over some of these problems. So A here, my starting value is $35,000. They told me that it increases. This is a key word here. Increases by 4% each year. That means R is equal to 0.04. Okay, to convert that to a percent, I shift the decimal to the left twice. And the fact that it's increasing, right, tells me it's going to be growth. So that B formula that I just mentioned, B is equal to 1 plus R in this case, right? So plus 0.04, therefore B is equal to 1.0. And so if I want to write the equation here, I could say Y, yeah, we'll use Y, is equal to 35,000 times 1.04 to the Yeah, question, comment? Mm-hmm. No, it will either say increases or decreases, or you'll have to determine that based on whether or not this number was bigger than 1 or less. Okay, so that's exactly how you would decipher that. You can close your Chrome. Here, I'm gonna go, I've got like 7 or 6 problems that I want to get through, so I'm doing one from each section. But I'll be able to look at with that with when we're reviewing the test after. R is the rate that it is increasing by, often written as a percent, but it also could be written as a decimal. So if B was 1.04, then that meant R was 0.04. T is time. T is like my input. Here, let's do a word problem. Let's get one of these done. So once again, let's see. I'm seeing increasing here. This is what I'm working with. Y equals A times 1 plus R to the T. I used plus here because it was increasing. So let's see if we can identify some of our values. A here, it says the population of a city has been increasing 2% annually. The sign shown is from the year 2000. So, aha, they gave me a clue, not in the word problem, but in the graphic. Sometimes math books do that. So A is 315,000. That's my starting population in the year 2000. Okay, so that's when we're going to consider that T is equal to 0. Oh. Wow, I didn't know that. So 11,000 where we live, apparently. Okay, let's see. Can I figure out what R is from this problem? What's R? So if R is equal to 2% and it's increasing, right? That's why it was a plus sign. So 0.02 is the value of R. %, written as a decimal, would be 0.02. And B will be 1 plus 0.02. So B is going to be 1.02. Yeah? So let's write this equation out then. So that means Y equals 315. That's a weird looking 3. That's fine. But 315,000 times 1.02 to the T. Thank you. And so this is my equation that represents the population of this city over time. Okay? And now they're going to ask us to use our equation to make a prediction about a future time period. Wow, that is future. That's even future for us in this video now. Unless Wait a minute. Like, what if they're watching this video in the year 2020 and maybe the world's already ended? That would be sad. And like that population, this model will no longer predict the population of Brookfield accurately. Who knows? So 2020, question. If T is equal to the number of years after 2000, 2020, T is equal to 20. Perfect. You knew exactly where I was going there. T equals 20. All right. So now I want to plug this 20 in for T, and we'll predict the population. So y equals 315 thou times 1.02 to the 20th power. Yeah, a little bit. So to calculate that, exponent before multiplication. That's right. Good call. Good call. So 1.02 to the 20, I get this. And I like to write this intermediate step because it gives us some insight into the problem. So I get 1.49, we'll call it. So that means, yes, it's growing 2% per year, okay? But after 20 years, it will have actually grown by 49%. It will be 1.49 times the original size, right, Ben? You can close your Chrome. Well, right. This is just a model right now, yeah. You're right. And actually, the further out I go, the less likely my mathematical models will be accurate. So usually a mathematical model will be pretty good within the range, within a certain range. But yeah, if I go out 1,000,000 years or 1,000,000,000 years, it's unlikely that this will be anywhere close to reality. Okay? So let's see. So let's figure out what this is. So what is 1.49 times 315.06? And I used actually the calculator's full decimal approximation of that. So my number might be a little bit more accurate than what I wrote here. So 468,073.4. Oh, 1,000. They said round to the nearest 1,000. Oh, okay. So I can just say this. So 468,000 population. Yep. City. That's according to this model, yeah. I don't know. Could be. Yeah, you could. Maybe they made it up. All right, let's look at this next problem, 21. Let's get cruising because I'm already 12 minutes in. Identify the initial amount A and the rate of decay. Notice, decay as a percent. Here, let's keep going. Like, watch me a few times and then it'll answer some of your questions. All right, so in this case, I'm using y is equal to a times 1 minus r to the t. I'm using minus because of the fact that it's decaying, decreasing. Right, Jimmy, you can close your Chromebook too. I just want to make sure you guys are all with me. So in this problem, A, the starting value is the 240. Okay. B is the 0.75. I got to figure out what R is, right? I think they asked for it. Yeah, find the rate of decay R as a percent. So if I want to find R, in this case, I'm going to use the, I'll write it over here. B is going to equal 1 minus R. No, that's 1 minus 1. 1 minus R. And so I could say 0.75 B is equal to 1 minus R. So if I want to solve for R, what could I doodly? Minus 1 from both sides. So I would get negative 0.25 is equal to the opposite of R. Yeah, 0.25 is R. They wanted it as a percent, so that's the same as 25%, yeah. So notice, if 75% remains, that means it decreased by 25%. Like, do you guys see how, like, without this formula, you might have even been able to, like, intuitively determine that? So if I told you that B was 0.8, then R must have been, right, 0.2. It was decreasing by 20%. Or if B was 0.1, then R was 0.9. It was reducing by 90% in order for 10% to remain. Okay, so I also would have known that this was decay because this value was less than 1. Yeah? Yeah. Okay, that's all they... Oh, they wanted us to find out when t equals 3. Man, I might not get through all the problems I want. Well, we'll see. So if t equals 3, let's find out what g of 3 is. So that's 240 times 0.75 to the 3. So that's 240 times 0.75 to the 3, and I get 0.4219. Round that out a little further. And so what I want to point out is it's reducing by 25% each year, if these are years. 75% is remaining after each year, but after 3 years, 42% remains. Okay, that's kind of what like this intermediate calculation gives me. And so now if I take that number in my calculator and multiply by 240, I find out that I get 101.25. They wanted the nearest tenth, so we'll call that 101.3. Okay, so that is a decay situation. All right. I mean, my internet friends could have long said goodbye, but tell you what, let's just do one last problem. I mean, they can always tune out if they wanted to, right? You know, like, not like they have to keep watching these problems. But I have a feeling that's probably helpful to us in the room and maybe to future mathematicians trying to learn how to do example 37 on the homework. So, determine whether the table represents exponential growth or decay or neither. Yeah, so notice, first of all, these aren't increasing by 1. They're going up by 5s for my x's. That's fine. But what's happening to the r values here? Let's see, yeah, times 4, times 4, times 4. So it looks as though, I was just going to try saying this, but that's not technically true. It's not 4 because these weren't increasing by 1. So it's something less than 4, but the fact that these are growing, all right, the fact that this is growing, it's still going to be exponential growth. Okay, so all you really had to determine was, are these getting bigger? And I guess determining exponentiality is it getting bigger by repeated multiplication, whereas a linear situation would have been repeated addition. All right, so bigger, multiplication, growth. Cool, cool, cool. All right, well, thanks for watching, internet friends. Have a great day.